Okay, these are the systems of equations in two variables. System of equations, a set of two or more equations for which there is a common solution. System of two equations in two variables. That comes from your manual. But the big thing is that if you have two variables, if there is a unique solution, you must have two equations. That's what I learned the hard way in physics. If I have three variables, I need three equations. If I have four variables, I need four equations if I want a unique solution. If I have fewer equations than I do variables, there's not going to be a unique solution to the system. It says verify that the coordinate point 4, 8 is a solution. That's easy enough. This says that x equal -4 and y equal 8 as your coordinate point, x comma y. And you just plug and chug. Is it true that 2 times x, which is -4, plus 3 times y, which is 8, is that equal to question mark 16? So -8 plus 24 is indeed 16, and it checks. Just because it checks in one doesn't mean it's going to check in the other. It's got to check in both, because it is a shared coordinate point. So is it true that negative x, which is negative a -4, minus 1/2 y times 8, is that equal to 0? Or is 4 minus 4 equals 0? The answer is yes, and it checks. So -4 comma 8 is a solution. Now here's the interesting thing. It doesn't mean it's unique. It just says it is. There could be more than one solution. We don't know. It just says, is it a solution? The answer is yes. It says solve the system graphically. And when you're talking about a system of two equations and two unknowns, basically there's lines at this point. So they're linear equations. Linear means lines. So that means that I have two lines. If there is a unique solution, I'm going to have two lines, and they cross at a shared point. That's your solution. So for me, I kind of like to use, and by the way, this is not a way that you really want to do solutions to systems, is graphically. I can check my answer graphically using my grapher. But I certainly don't usually solve systems graphically by hand. Well, why? Because my pinpoint is wider than the solution might be, because if I had 1.5 as a solution on x, I'm not sure whether my little dot looks like 1.5 or whether it looks like 1.4. Does it look like 1.6? Don't know, because of just the width of my pen. And when I take my straight edge, whatever my straight edge happens to be, whatever you have handy that you use as a straight edge, right, you may not have it lined up quite right. But if I've got something that looks like this, x minus y equals 4, I usually don't use slope-intercept method of graphing. I normally just use what I call the intercept method, so that if x equals 0, I cover the x up, y equals -4, and if y equals 0, cover the y up, x equals 4. I only need 2 points for a line. But by the way, if I were doing a graphical solution and I were doing it by hand, and it mattered whether or not the bridge was going to fall down or the shuttle was going to land in the right place, right, I'd do the third coordinate point because they should line up.
Yeah, that's backwards.
If x equals 0, y equals -4.
No, it's x minus y equals -4.
Oh, this is -4. So it's not backwards. I've lost my sign is what you're saying. So this should be +4. So that's what you mean by backwards. Okay, thank you. So I would do the third point just for the check. But so, in this case, a third point would have told me that I was off. So x equals 0, y equal 4. Now, what's really weird about this graph paper is that the number is above the point, not on it. So it's above it, so that's 4. And negative 4, 1, 2, 3, 4. Whoops, I'm sorry. It's 0, negative 4. Or negative 4, 0. That's more like it. And then I find a straight edge. You use whatever you have handy. And if I don't have anything that's really handy that's good, which I don't seem to have, I'll take just a piece of paper, fold it. That's a straight edge. Right. Now I just line it up as best I can. And that's when you hope for the best. And this ends up being x minus y equals negative 4. And I'm going to change pen colors. And if I wanted to, this is x plus y equals 6. I could use slope-intercept. Y equals negative x plus 6. Here the slope is negative 1. Slope negative 1 means if I have a coordinate point, this is negative 1 over 1, I go over 1 unit and I go down 1 unit from 6. So that says the y-intercept is 6. Again, 1, 2. I don't like this graph paper. It says it is above 1, 2, 3, 6. So it's a 6. 1, 2, 3. I'm off 1. I'm off 1. I'm off 1. And that's what I get for choosing this graph paper. Because there's, no, I'm okay. That's 4. 5, 6. So 6 over 1, down 1. Oops, can't even draw a straight line with a straight edge. And it looks like it's x equal 1, y equal 5. Maybe. So my guess is, in this instance, from the visual. Well, we can check. Is x minus y 1 minus 5, is that negative 4? Yeah. And is 1 plus 5 equal to 6? Yeah. So indeed, my guess is correct. It's x equal 1, y equal, or x equal 1, y equal 5. Now your book is asking you to write your solutions in terms of coordinate points, 1, 5. Because that's what they have in common. They have a common, that shared coordinate point.